Simply Math.
Hi there, my name is Noel Jeju.
And I'm Neil Jeju. Over the past year, we've been tutoring math online for children, and we realized that we could reach out to far more students and share the joy of math through our YouTube channel, Simply Math.
Through this channel, we will cover high school mathematics, including Algebra 1, Geometry, Algebra 2, and much more.
If you have any questions or suggestions on how we could improve, please leave them down in the comment section.
Please make sure to like, share, and subscribe to our videos. Thank you.
Hello everyone, welcome to Simply Math, and in today's video we're going to be talking about irrational numbers. We're specifically going to be covering these two topics. Number 1, what is a rational number versus an irrational number? And number 2, classifying rational versus irrational numbers. So, let's get straight to it. Number 1, what is a rational number versus an irrational number? Well, a rational number is a number that can be expressed as a ratio of two integers. Over here, m and n are both integers. And because a ratio can be rewritten as a fraction, this can be rewritten as m over n. And this way of writing rational numbers as fractions is what I'm going to be doing all throughout the video. And now, just by the name itself, we know that an irrational number is the opposite of a rational number. Therefore, if we have an irrational number, let's call it x, we know that it cannot be written as a ratio of two integers. So, now that we've defined what a rational number is and an irrational number, let's talk about how we can classify them. First, let's focus on rational numbers. Rational numbers can be either terminating or repeating. Now, what does that mean? What does it mean when a number is terminating? Well, I'll describe it through an example. Let's take 17. 17 is just these two digits, right? After this, it's just zeros. And so we can say that the number essentially terminates right over here, after the 7. So, because it has a finite amount of digits, and after a given amount of numbers, it's just zeros, it's a terminating number. Another example is negative 2.35. And I know this time it's a negative number, and it actually has values after the decimal, it's still a rational number and it's terminating. The reason is because it just has these three digits. After this, it's just zeros. And so, in general, when you have a limited amount of digits, even if it's 100, after a given amount of points, it just stops and becomes all zeros after the decimal, then it's a terminating number and it's rational. So, now let's talk about repeating. Numbers that are repeating, unlike terminating, they go on forever, but they still have a repeating sequence. So let's talk about an example. 1 over 3. This can be rewritten as 0.33333 on and on and on. Or in other words, 0.3 with a line over the 3. That line indicates that the 3 goes on forever. And so, it's not terminating, but as we can see, the 3 keeps on repeating. So, this is still a rational number and it's repeating. Let's talk about another one. 0.142857 repeating. Now, this may seem like a weird number, and it's much longer than 3, but it's still a repeating number, and it has a repeating sequence of 142857. This actually happens to be equal to 1 over 7, and this 1 over 7 has many interesting properties about it, and I'll be talking about that in a separate video. So, now that we've talked about rational numbers, with them being either terminating or repeating, let's now talk about irrational numbers. Irrational numbers are non-terminating and non-repeating. Now, what does this mean? This means that, unlike a terminating number, it does go on forever. But unlike a repeating number, it does not have a repeating sequence. Now, over here, I wrote down 4 of the most commonly used irrational numbers. We have pi, e, phi, which is the golden ratio, and the square root of 2. Now, all these numbers have their own unique uses, with pi being used in circles, e being used in compound interest and higher level math, phi as the golden ratio describing many interesting properties, and the square root of 2 just being the square root of 2. Now, Over here, we have a very interesting number. 0.171771777, on and on and on. So, this may seem like it's a repeating number and it's rational, but it's actually irrational. And not just because it's colored in blue. Over here, you can see that 17 is here and then 177. Although this follows a pattern, it doesn't have a repeating sequence. Because 17 is not the same thing as 177, and that's not the same thing as 1777. So, this is still an irrational number. Now, one more thing to clarify is that I said that this over here, phi, is the golden ratio. You may be wondering, if it's a ratio, how can it be irrational? The answer is this. Phi represents when two numbers are in this ratio. A divided by B is equal to A plus B divided by A. So, this only happens when A and B are not integers. Therefore, it's still an irrational number. If A and B were both integers, then phi as the golden ratio would be a rational number. But because they're not integers, phi is still an irrational number to describe a ratio. That's all for this video. Please make sure to like, share, subscribe, and leave a comment down below. Thanks for watching.